Roger that. Ready for
Booster
liftoff.
plane. Status booster.
Go.
GNC.
Go.
Go ahead, throttle up, Capcom.
Off to explore
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Oh, we got it. We got it.
Bill Nye the Science Guy.
Maybe it's this button.
Brought to you by Armstrong Moon Boots with the patented lunar springy step insole.
We live on a big round rock, hurtling through a vast emptiness. Space.
10, 9, 8, 7, go for main engine start.
Now, space exploration
5, 4, 3, 2, 1.
is how we've come to know that we live on a planet.
And liftoff of Space Shuttle Atlantis.
In space.
The Russian docking module, the threshold to world cooperation in space.
The distances are huge, and it takes many, many people working together to pull it off. Now, to even get started, we need a big boost. A big lift. A big push. For space exploration, we need one of these. Yeah! Woo! Woo! Yes! Yes! How do we even know there's something out there to explore? See, humans weren't always riding rockets. For tens of thousands of years, humans did all their space exploration from the Earth, looking up at points of light in the night sky. A few hundred years ago, people had the idea to use a magnifier, a telescope to look at the sky. And when they did, they saw that some of the points of light that look like stars are actually planets. They have different colors. And some of them even have moons going around them, the same way our Earth does. Space is huge, it's vast, and it's where we live. The very first tool for space exploration was right here, and we used it like this. Thousands of years later, we enhanced it with an instrument like this. And then, like this. And then like this. This is the Clark refractor in Flagstaff, Arizona. It's 10 meters long, and it's got a lens on it that's like 60 centimeters. It's like that. It's all set up so you can look through here. And like this. It's the Hubble Space Telescope. It's in orbit, way above the Earth's atmosphere. It has a much clearer view of objects in the universe than we can get from our planet's surface. See, never before in history has any human seen images like this. Space exploration telescopes that magnify patches of sky. Space. Why do our rockets that go up in space have to be so big? Well, please consider the following. It's our hot rod on a string of science. It's a car. And one end of a string is tied to it. And the other end is tied to this ball. Now gravity pulls down on the ball. And the ball pulls down on the string. And the string pulls on the car and pulls it toward the center of the model. The center of the model, pulling on the car. Now here's the thing. Space is only 300 kilometers from here, only 200 nautical miles from here. So if we could drive a car at, say, 100 kilometers an hour for 3 hours, well, we'd end up out in space, and I guess we'd pull over and park. But we can't do that. You know why? Because gravity will pull the car right back down. Right back down. Right back down. So here's what we do. We get our rocket ships moving. Now the car wants to go up this way in a straight line. This way. And gravity is pulling the car that way. So what ends up happening is the two forces are in balance. The car goes around in a circle. The same thing happens with our spaceships going around the Earth. They end up in orbit. Even though they're still being pulled down by gravity, they go around the Earth. So they never fall down. They fall around the Earth. Now, to get a rocket like the Space Shuttle in orbit around the Earth takes about 100 tons of fuel. And to get a rocket to leave the Earth and go to someplace like the Moon takes 6 times that much fuel. See, that fuel takes up a lot of room. So rockets end up being big, 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 big. In fact, to get rockets into space, we need a huge amount of fuel. We need a gas tank 5 times bigger than a spacecraft. That's because gravity is holding our rockets down, keeping our rockets from leaving the Earth until we get them to blast off. This is the Saturn V, the largest rocket people have ever made. It's over 120 meters long. Almost all of this is for the fuel. It's enough fuel to get you to the Moon.
Flying over at 60 miles.
And back.
Tranquility Base here. The Eagle has landed.
That's one small step for man,
One giant leap for mankind.
I was rolling on the moon one day. Man, that is hard. Just don't stub your toe.
Jack Schmidt having a few problems.
My golly, this time goes fast.
How about an extension, you guys? We feeling good.
Right away, Houston.
There's gonna be a launch in a few weeks. Oh, okay, here's the deal. 45 tons of solid fuel in each of the white rockets. 73 tons of liquid fuel in the big orange gas tank. And all that is to take the Space Shuttle Columbia, 5 people and a busload of luggage, into orbit, 120 nautical miles above the Earth's surface. You see, it takes a big machine. Space travel is a big deal. We're on the gantry tower of Pad 39B. That's Pad 39B. That's the Space Shuttle. That's the elevator that the astronauts use to get up here. That's the arm they walk down to get inside. Those are some of the pipes and electrical connectors used to start the engines. See, the gantry tower is a big machine to launch a machine. This is the White Room. It's where astronauts wait right before they get on the shuttle. In a few weeks, they'll go through this hatch, we'll button it up, and they'll be out of here. Maybe you'll go through this hatch someday. There's the shuttle, 5 kilometers away. It's connected to this room, where 250 people control the launch. Once it's off the ground, thousands of people around the world run the mission.
One. Liftoff of the Space Shuttle Columbia on an international life science and microgravity mission.
Houston now controlling the flight of Columbia.
Houston, Columbia's in the roll program.
Now, right now, the spaceship is hurtling up into the sky. Up, 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 and everyone on board is being pressed back into their couches, and the pressure is more and more on the outside of the spacecraft. It's distorted.
Go for main engine start.
2. We have ignition sequence. On an international life science,
Appeared either by the launch vehicle.
Almost everywhere you go in space, there's nothing. It's empty. There's zero, nada, zilch, zip. That's because space is a vacuum. It's a void. It's almost devoid of everything. That's why astronauts have to wear spacesuits. Take a look at this. It's our vacuum of space, vacuum chamber of emptiness, of space, of science. And this is cherry soda. Soda has gas in it. You've seen the bubbles. Well, your blood has gas in it too, like oxygen and nitrogen we get from the air we breathe. Now watch what happens when we put the cherry soda in a vacuum. As we take the air out of the chamber, there's no air above the liquid to hold in the bubbles. So the gas comes out of the soda. See, the same thing would happen to you in space if you were in the vacuum without a spacesuit on. That's why astronaut spacesuits and spaceships have to be airtight, or human bodies wouldn't work. Look at that. This would be like your blood in space, and it would be boiling in the vacuum of space.
Bill.
Well, go ahead, do a fancy edit. Make me say, vacuum. Vacuum. When you go out in space, you've got to dress right because there are extremes of temperature. It can be very cold or very hot. Well, to keep astronauts from getting too warm, they wear this garment. It has little tubes in it with liquid cooling water running through it. That way, you're always comfortable. The way to put this on is to lie down. Very cool. See right here? This can twist. And you can move your fingers too. Space is a vacuum. There's no air. But we come from the Earth. We've got to have air pressure around us all the time. That's why these spacesuits are airtight, and they've got their own supply of oxygen.
We're sealed in, ready to pressurize the suit.
make sure everything's locked. And
Pressurizing.
you're at 1 pound of pressure now.
1 pound. Yours are popping. Well, the suit's pressurized, the cooling water is flowing, and the breathing air is pumping. You can think of a spacesuit as a self-contained spaceship for one. My nose itches.
Place EV1 in the water, please.
Moving and working in a spacesuit is difficult. So astronauts practice. We rehearse in a big pool like this one. This is a model, a mock-up of the space shuttle. So we can put anything down there in the cargo bay that we'd want to take up into space. That way we can rehearse, we can practice the tasks we need to perform once we're out in space. Spooky. If you're not secured to something, when you go to move something heavy around in space, Instead of the thing moving, you move. When you're working in space, it's good to have a place to stand. That way you can use your hands without floating away. So these are foot restraints. They're real handy. Well, I mean, they're real footy when you're in space. With the foot restraint, pushing something like this around is easy. Well, it's easier. When you're out in space, tasks that seem pretty easy on Earth, take for granted, can be pretty tough. Like here's a doorknob. If I go to turn the knob in space, I'm the one who ends up turning. Ugh. When you go to do a task like that, we'll use this right here. Then you can gently open the door. Foot restraints. Handrails. Okay. Rehearsing for dance.
My name is Sheikh Diarra. I'm an interplanetary navigator. My job consists in steering spacecraft to their destination planet. I have flown several missions, and actually now I'm working on the Mars Pathfinder, the micro rover, and it's capable of moving on the surface of Mars. And these missions, to design them, require a very high level of complexity because we don't know when the sun is going to flare, and every time the sun flares, it just pushes the spacecraft off of its course. You have to take them into account and make your calculation and determine what is the 99% chance amount of fuel, minimum amount of fuel, which gives you 99% chance to do the whole mission. And once you determine that you have the size of your tanks, you have the volume they occupy, the spacecraft architecture is done around that so as to fit in the fairing. I mean, it's complex. And you have thousands of sub-elements like this. And the next challenge is the atmospheric entry, because before we get there, we have to position the spacecraft in its entry position. If you come in too steep, you get burned. So we have a nice narrow corridor. We enter in that corridor at 17,000 miles per hour, and in less than 2 minutes, we slow down to 900 miles per hour, at which time we can open parachute, and that will help us slow even further down, and then we inflate the airbags that surround the cocoon in which the spacecraft will be. Then this big beach ball, which is about 50 feet diameter, will just come and hit the Martian surface. When it comes to a stop, we deflate the airbag and we open the lander up like a flower. The adventure of space exploration is just beginning. It is at its infancy, but there are so many more things that we can learn. So many things we don't know about our own solar system, about life existing somewhere else or having existed even in our solar system in the past. And because of the availability of technology today, everybody can take part in this exciting adventure.
And now we join Bill Nye on the surface of the moon as he steps carefully down.
She loves outer space, she wants to go there. She's in your face with the wild hair. She's space girl, and she's out of this world.
Right now, you and I and everyone else we know, we're on this tiny spaceship called Earth.
Life in space is very different than life on Earth. Everything you need, you've got to take with you, because outside is a pretty harsh environment. The view out the window is pretty different. Anytime you use water, well, you have to keep it from floating all over the place because there's no gravity. So if you wash your hands, you've got to do it in a box. Keep the water from going all over the place. When you take a shower, the water doesn't drip down, so you have to vacuum it off with this thing. Now, when you use the toilet or go to the bathroom, you've got footrests, handholds, and a vacuum system. It's pretty involved. Now, the space station is going to be built of big pieces, big modules like this one, and they're all the same size. The experiments are the same size, too. So whether you're doing an experiment on growing crystals, melting metal, they're all in these racks. When you're done with the experiment, you just float the rack out and haul it back down to Earth. There's racks in this wall, and this wall. So you got to use all the space when you're in space. What do you think? Living in a little room like this for 3 months? Could you do it? When the space shuttle comes back from space, it's going so fast that it would burn up in the Earth's atmosphere. Take a look at this. These tiles are over 1,200 degrees Celsius. Watch. That's hot. Now look, as they cool, in just a few moments, the edges turn gray, and you can do this. Isn't that wild? See, this material dissipates heat so fast that the space shuttle can come back without burning up. You gotta have it to get back. Don't leave the Earth without it.
So much to see in the galaxy. Come explore the planets all. Come explore the planets all. Splash me down, take me up. Show me asteroids and dust. Space is what we see. Astronomy from this world called Earth. With a telescope, you can see Mars heights or a satellite. Baby, look up high. It's a starry night. Millions, billions, trillions. I can see space light.
Well, that's our show. Thanks for watching. If you'll excuse me, I've got some interplanetary atmospheric weather conditions to compare. See ya! It's beautiful, isn't it? Look at that expanse of atmosphere. It's held on by gravity, you know. The same thing's true on other planets.
Produced in
Same deal.
association with the National Science Foundation.
This is where I live. I mean, it is unique. This is my home planet. But other planets have the same setup. I seldom go there, though, because space is so vast, so huge. Even as you're watching this show, the stuff that you're seeing and the words you're hearing, they're going off the planet, out into space, way out, out, where no one will ever go. Probably. I mean, that's alive today. The deal is, everything in space is really far apart, because most of space is what? Space. Empty. Space. Hugely, bigly, far apartly, hugely far things in space.
Divers for Bill Nye the Science Guy, please bring him to the surface, to the docking station.
Hey, you guys, let's all go in there and explore space. Space exploration.